Good evening, students. This is Deekam Pathak from Freebird's Experiences. I welcome you all to day 5 of Fun with NCERT. So today's session will be taken by Ms. Nupu Chaudhary. So without any further ado, Ms. Nupu, kindly please continue on with this session. Thank you.
Thank you so much. So dear students, welcome to yet another session with Fun with NCERT. And today we will be discussing with some very interesting topic related to our science, which is already there in our science books. Okay, so force and pressure. So when we are talking about force and pressure, we will take both the factors or both the term individually, and we will try and analyze what is there in each of these. Okay, let us talk about force first, and then gradually we'll move ahead with pressure. So talking about force, what is the first thing that comes to your mind when we talk about force? So suppose we punch someone, or let us say we drop something on the floor, or let's say we push or pull something. So all of these constitutes force. That means all of these will need force. Even to lift something from the ground or drop something on the ground, everything is dependent on force. So force formally can be defined as the push or pull on an object with mass that causes it to change its velocity. Velocity is another term, we'll discuss it slowly. But first of all, you have to understand that force is just a push or a pull that you give on an object, or we perform on an object, either a push or a pull. And that object essentially need to have mass. Its SI unit is Newton. That means whenever we represent what is force or what is someone's force, or what is the force by which an object is hit, or what is the force by which an object is stopped, we give it a unit, or we associate a unit with it, which is known as Newton. It is same like kg, or it is same like liters or centimeters or meters, whatever unit you give for different entities. So here also, for this force entity, you will have a SI unit, which is known as Newton, right? Now, talking about the direction of the applied force. So whenever we are applying force on something, definitely it will have a direction, and that direction will change. That direction will be changed with respect to the object, whatever we are taking into consideration. That means if we are pushing or pulling an object from one direction, that impact of that force is different when we are pushing or pulling that particular object from a different direction. So the next point we have to remember is that if we are adding multiple forces in the same direction, the forces will get added up. And if we are applying force from opposite direction, the forces will get subtracted. Right? So these points we can describe it through a small experiment. So let me flip the camera so that I can demonstrate these 3 points to you. Stop presentation. So can you see my screen? Can anyone confirm? Okay, thank you. So when we are talking about the impact of the direction of force, so suppose I have this object with me, right? Let me consider the mobile phone which I have as an object which I am going to consider for my experiment. Okay, suppose this object, if I am pulling or pushing the object from this direction or from this direction, I can pull or push the object from the right direction or from the left direction, or maybe from the front or from the back, right? So all these directions, through all these directions, I can push or pull this particular object. So whatever impact it is generating by pushing or pulling this object from this direction, the same impact will not be there when I'm pushing or pulling the object from this direction, right? So this point, I believe everyone is clear about this. The next point is, suppose this is my object, I am applying a force. That means I am applying a push to this object from this direction. Okay? One more force, if I am applying, that means if I am using both my hands in order to push this object could be moved easily, right? So the force that I'm applying with this hand and the force I'm applying with this hand, both of them will get added up and the object would be moved pretty easily. But if that means both the forces are added with each other. Now, if I am doing just the reverse of this, that means I am applying force from this direction and with the other hand, I am applying force with the other direction. Now what happens? I'm trying to push this object, but this object is not moving much or it is in its own position, right? That means the forces get subtracted from each other and through whichever hand I'm being able to apply more force, I can move the object towards that direction. So multiple forces, if I'm adding in the same direction, it gets added up and we can shift the object or move the object easily. But if we are applying the same force from the opposite direction, we will find that the total force on this object will get subtracted and there will be minimum shift in the position or we will not be able to move much, right? So all these points, I believe it is clear. So let me proceed with the presentation now. Okay, so the screen is visible, I think. Okay, thank you. So the next points that we will be discussing is, first one, the force can make a body that is at rest to move, and the second one is that it can stop a moving body or slow it down. So first of all, let us discuss the first point. That means if a body is at rest, that means the object is at rest, means it is not moving anywhere. It is just lying in one position. So it will, when we are applying force to it, that body at rest will move. Now, the second point is that it can also stop a moving body or slow it down. This is just the opposite of the first point that we have discussed. Suppose a body is already moving. Here we are calling the body as an object, okay? We can consider it as an object. So if an object is already moving, it will either stop that particular object or it will slow down the pace. It can also slow down the speed in which it is moving. The third one is that it can accelerate the speed of a moving body. That means if an object is already moving, okay, if an object is already moving, so if you are applying force into it, the speed will be increased. That means it will move with a greater speed than what it was already moving with, okay. The fourth point is that it can also change the direction of a moving body along with its shape and size. So whenever we are considering a moving body and we are applying some sort of force into it, it can change the shape and size of it as well. So all these points we can illustrate with activities, right? So again, I will be flipping my camera so that you can see the experiments. Okay, so as you can see, I have a blue ball in my hand. Okay. So the first point was that the force can make a body that is at rest to move, right? So suppose this ball is at rest, okay? Let us consider this is at rest. Now, if I am applying force, is it moving anywhere now? When it is at rest? No, it is not moving anywhere. Now, in order to make this object move, I have to apply some force into it. Okay? So this is at rest now. I am applying some force into it. Now it is moving. Okay? Now it is moving. Right? Now it can also stop a moving body or slow it down. Now suppose I am moving, this object is already moving. I will apply some force to stop it. Right? So now the moving ball, the ball was moving initially. So now when I'm applying some force into it, it will stop. Right? Now it can also accelerate the speed of a moving body. Suppose this body is already moving. So I will apply some force into it and it will move at a faster speed than the normal speed that it already has. So this is the normal speed it has. I'll apply some force and it will move at a faster speed now. Okay. So the third important point is it can, the fourth, it can also change the direction of the moving body along with its shape and size. Now, this ball was moving in this direction. I can make it move in this direction, right? So it is moving in this direction. I will make it move in the opposite or some other direction. So applying force, we are applying very minimal amount of force, but we are applying some force in order to change the direction of the moving body, right? And the shape and size can also be changed, because if I press this ball, I'm applying some sort of force into it, right? So when I'm applying some sort of force into it, you can see that it is getting depressed, right? The ball got a depression in it, or the shape of the ball got changed, right? So I have applied some force into it, hence this depression has occurred. Otherwise, it was a round ball which we considered for our experiment, right? Again, I can bring it to its normal shape by the application of some amount of force, isn't it? Now, you have to understand that all of these, that means the ball which is at rest can be made to move, or the moving ball can be stopped, or we can accelerate the speed of the ball, okay, or accelerate the speed of the object, or we can change the direction of the ball, or we can change the shape of this object or the ball. All of this can happen together, or multiple, 2-3 points can happen together, or none of them can happen at all. By this statement, what I mean is that, see, when I'm considering this object, so the ball, the resting ball, the ball which is at rest, I can make it move with an accelerated speed by changing its direction. So I'm making it happen all of it together, right? I can also change the shape of the ball if I want by pressing it, isn't it? So all of this can happen together, but it might not happen at all also. It will depend upon the object that we are, or it will depend upon the body that we are exerting our force. Suppose if I consider the wall which is behind me, whatever I try, however I try to push or pull this particular wall, I will not be able to move this wall. Okay? Neither I will be able to change the shape of this wall or do any sort of experiments or any sort of effects of force which we have already discussed with this particular wall. So it will definitely depend upon the subject on which the force is applied. Only if we can identify the subject or the object with which we are experimenting, then only we can identify whether our force will exhibit this effects or not. Okay, this ball and this wall is not same, so you have to be very sure when you are working with these kind of experiments. Okay, so talking about okay, so I'll just share my screen again. So this we have already discussed. Sorry. So this we have already discussed. All of them can happen at once or none of them can happen at all. Okay. So with this ball, the ball that we saw, everything can happen at once or practically none of them can happen at all. Right. When we are considering the wall as an example. Okay. So let's move to the next part, which is types of force. Now, when we are considering types of force, there are two types of force which are based on their applications. The one is contact force and the other one is non-contact force. So when we are talking about contact forces, in contact forces, the objects needs to have contact with each other. However, in non-contact forces, there is no such requirement. We will look into it in details in the next slide. Okay, so contact force, basically, they are muscular forces, right? So what do you mean by muscular force? In your class 6 syllabus, you have already seen that whenever you lift something, you have biceps and triceps and body muscles, which will contract and relax based on the type of activity which you are doing. Right. So whenever you're lifting something, your muscles, the tricep muscles and bicep muscles, they get contracted and some other muscles get relaxed. Right. And according to your muscles or your body structure, the force which you will release, that is known as, or the force which your body releases through your muscles is known as the muscular force. Right. That is seen in weightlifting, and whenever you're doing some heavy kind of work, you are making your muscles contract and relax. Okay. The next contact force is mechanical force. Now, in muscular force also, you have to see that, you can see that the object and the subject on which the force is applied is in contact with each other. Right. They're in contact with each other. The second one is mechanical force. Mechanical forces are those forces in which you change the state of an object. Suppose here in this slide, you can see that there is a person who is closing a door. So the door was initially open. Now the door shifts from its original position and it gets closed. Okay, so we are applying some sort of mechanical force which will change the state of the object on which the force is applied, right? So you are in, or the force is in direct contact with the object, all right? Now, the third kind of contact force is frictional force. I believe all of us have seen cars or you have seen, all of us generally see those cars which are running on the roads, right? Or we also have bicycles. We have also ridden bicycles. So we have gone out to the roads to get a good ride. Okay. So this frictional force, generally, we can observe it on the roads. Not only on the roads, it is basically on the ground, and it occurs when two bodies come in contact with each other. Generally, the direction of the travel, that means in whichever direction you are traveling. In this picture, you can see the car is moving towards the right. The frictional force always occurs towards the left. Okay. So frictional force is always opposite to the direction of travel. All right. So here also the bodies needs to be in contact with each other. Now coming to the second important force, which is non-contact force. So when we are talking about non-contact force, you have heard about gravitational force, right? The earth has gravitational force. Now, what is this gravitational force? Have you ever observed when you throw something up, the let's say if you are throwing a ball upwards, the ball does not remain in the sky, it falls down, right? Similarly, other things also, whenever you drop something, it generally falls down on the ground, isn't it? It never goes up or it never floats on thin air. That force which pulls an object towards the ground is known as gravitational force. Okay, this is also seen in between different planets. How do you think the moon rotates or it revolves around the earth? You all of us have seen moon, right? So the moon, we also know that the moon revolves around the earth. So how do you think the moon has the capacity of not falling down anywhere and it simply rotates, revolves around the earth? Because it has some kind of force, the earth is exerting some kind of force on the moon so that the moon is tied to earth and it will simply revolve around it, right? However, gravitational force is a force which always acts downwards. Okay. The next non-contact force is, so in gravitational force, you can see that the apple here in this picture, if you see, the apple is falling from the tree to the ground. Okay. So in between, there is nothing but air. So they are not in contact with each other, but the ground is exerting some sort of force on this apple, and because of this force, the apple is falling on the ground, right? So this is known as gravitational force and it is purely a non-contact force. Okay, next we'll talk about electrostatic force, and for this we will have a small activity, okay, so that we can see how electrostatic force works. But before that, let us discuss, this is misprinted. So this is magnetic force. So here what happens is, this is a magnet and there are some nails which are there. So whenever you're working with a magnet, if you have a magnet at your place, you just take it near to some iron particles. You will see that these nails, even if you keep it at a distance, it will get attracted towards the magnet, right? So they have this magnetic force in between them. Please ignore this typing mistake because this was just overlooked, I think. So whenever you are using this magnet in order to attract some nails or some iron particles, these nails and this magnet is not in contact with each other, but it exerts some sort of force which will pull this nail, and these nails gets attached to this magnet. So this is magnetic force. So this is also a non-contact force because initially there was no contact with each other. We have electrostatic force and we also have buoyancy force, which we will be discussing with some experiments. Okay, so I'll just stop sharing the screen and okay. So a small demonstration of how electrostatic force works. Now I have a sheet of paper, a small sheet of paper, and I have this comb with me. Okay, so now what is my job? What will I do is, I will break this. Can you see this? I will tear this. Okay, we will tear this sheet of paper into small pieces. Okay, small pieces. I'm placing it on this particular screen because it will be more visible. Okay. All right. So I think we have sufficient of this. Now, when I am simply bringing, this is a comb, okay, and this is a very normal comb, plastic combs that we have in our houses, okay. So now what happens, I'll bring this comb near to these sheets of paper, pieces of paper rather, not a sheet of paper, these pieces of paper, but these pieces of paper do not move, okay. Now what I'll do is, I'll simply rub this comb in my hair, okay, and I'll bring it here near the pieces of paper. Can you see some of them are sticking to the comb? Is it visible? Or I think I should bring it closer to the camera. Okay, let me see. I'll do it once again so that it is visible. So this is the comb. I'm rubbing it against my hair. You can comb also, okay? I'm simply rubbing it against my hair and I am bringing it near to the pieces of paper. See, it is getting displaced from its position and it is getting, some of them are also sticking to the comb. Okay, so what happens is basically electrostatic force. There are some charges which gets accumulated in the comb due to rubbing it in my hair, and this electrostatic force which is generated with this comb makes the pieces of paper get stuck to my comb. Okay, so I'll have to rub this properly. I'll show this experiment once again so that it is much more visible. Okay, so when I bring this, see, one of them is sticking into the other also got stuck. Okay, the third one is also getting stuck. So it gets, the more you comb your hair, the more will be the charge that is generated in this particular comb, and the more will be the force, the electrostatic force. Okay, the second experiment which we will be doing for non-contact force, that is one more force we have for this, one more example of force which is known as the buoyancy force. Okay, that is also a non-contact force. Here what you saw that when I was rubbing this comb in my hair and I brought it closer to the pieces of paper, it got stuck. Okay, so there was no contact between both the objects. This object was exerting force, okay, and the other objects were the pieces of paper. So there was no contact. However, it got attracted to the comb, right? So this is a typical example of a non-contact force. One more force which is known as non-contact force, we will be seeing this with another example. So here I am taking a glass, all right, and in this glass I am filling some water. So basically these experiments you can carry out at your own houses without any additional things. Okay, so now I have an egg with me, all right. So when I'm putting this egg inside the glass of water, I put it very slowly because if I just drop it, it might break. Okay, so I'll put it very slowly and I'll observe. Now when I'm putting this egg inside the water, what happens? The egg sinks and it goes right to the bottom of the glass, right? Let me take it out once again and drop it. So I'll take out the egg once again. Okay. So this is the egg. It's any normal egg that you can get at your homes. Okay. So this egg, when you are putting it inside this particular glass of water, I'll put it slowly. All right. So again, it sinks. It is not floating on the surface, right? Or it is not floating anywhere. It is just it just got down to the bottom of the glass, right? So there is no such major, what do you call that, change. These things happen. If you drop anything inside a glass of water, it will go down, right? Now, what I'll do is that in the same glass of water, I'll take out the egg first, okay? In the same glass of water, I will be adding common salt which is available in our house. Okay, so I'll add some salt, put a decent spoon. Okay, and mix it up well. Okay, mix this well. So I'll put some more in order to avoid remixing again. So let me see. I'm putting some more salt into this and I'm mixing it properly. Okay. The salt should be dissolved in water properly. It should not be accumulated in the bottom of the glass. Okay. It should be properly dissolved in water. Now what I'll do is that this same egg I will take and I'll slowly place it inside the glass. Okay. Now can you see? Can you see the difference? What happens? The egg is floating on inside the glass. It is coming, the egg has come to the surface of the glass, right? Surface of the water. Isn't it? The egg is not sinking, it is just floating on the surface of the water. Right? This is not magic. This is happening because when I am adding salt in the plain water that initially I had, it increases the density of the water. Okay? So when the density is increased, it will also increase another contactless, what do you call that? Force, okay? Which is known as the buoyancy force, all right? And this buoyancy force always act upwards and it will make the egg float on water. So this is another type of force. Basically, we do not simply categorize it just on the basis of their properties, but on the basis of their applications. There are several such experiments which are already mentioned in your textbooks. Please go through them so that you can do more of these kind of experiments. Just 1 second. इसमें wait for the close the Am I audible? Okay. Sorry for this, but suddenly my connection it got disconnected.
Yeah, no, it's completely fine. It's fine.
Okay. So the next thing that we will be discussing is pressure. So pressure is just another factor which is highly associated with force. Basically, it is the ratio of the force applied to the surface area over which the force is applied. That means whatever force we are applying on a particular area perpendicularly, that is known as pressure. Okay, and the SI unit of pressure is known as Pascal. For force we have Newton, and for pressure we have Pascal, right? So we have to understand that pressure is equal to force by area. So whatever force we are applying, that means with whatever intensity we are applying a particular force, that force, and whatever area we are considering, that area, we have to take the ratio of both of this in order to calculate the pressure. Okay. Talking about the FPA triangle, okay, so this is basically force, pressure, and area. So using this triangle, you can find out the values of force, pressure, or area if any of the two parameters are given. And you also have to understand that pressure is inversely proportional to area. By this statement, I mean that whenever we are saying that the pressure exerted on a particular area is high, that means the area has to be smaller. Okay, so if you take the example, suppose you're walking on sand and you are walking with a flat shoe and a heel shoe, okay, a shoe which has a pointed heel. So which particular shoe do you think, which one do you think would be a comfortable, you will have a comfortable walk? Okay, definitely the one with the flat shoe, you will be able to walk better over sand. Why? Because there the pressure is less, because the area is bigger and the force is distributed. However, with pointed heels, you will not be able to walk because the area on which the force is exerted is very, very small, and hence the pressure is very, very high, right? So in solids, we have already, discussed about how things work with forces. Now, solids also exert force. All of us have knives in our houses, right? All of us have knives. So why do you think those knives have a very, very thin edge? There is a very, very strong concept behind this. The knives have very, very thin edges so that whatever pressure is generated with the force applied on that knife is highest, because with that thin side, the area is also less. So whenever the area is less, the pressure would be more, and whenever the pressure is more, you will be able to cut the things better. Okay. Similarly, you think about another example. That means whenever you're trying to hang a wall hanging on your wall, okay, so you use nails, right? So whenever you're using nails, why do you think the nails have pointed edge? That means whenever you're hammering a nail inside the wall or drilling a nail inside the wall, that nail has a very pointed edge, right? And through that pointed edge only it can go inside, isn't it? Now, why do you think it is not designed in a flat way? Or why the opposite side of the nail is not used to be drilled inside the wall? Only the pointed side is used. Because the area in the pointed side is very, very less. Okay. Hence, the pressure generated would be tremendous with lesser amount of force. If you take the opposite side, that will also go inside, but you have to apply a lot of force, right? So hence, if you have a larger area, you have to apply more force. Okay, and the pressure also will be lesser. Okay, but if you have a smaller area, the pressure would be higher, right? So Now we will see, we talked about solids and we saw that solids already exerts pressure, right? Now what about liquids and gases? Liquids and gases also exerts pressure. The more the depth, the more is the pressure in case of liquids. Okay, we will see this with an example, right? And the air around us will also exert pressure, and that pressure is known as atmospheric pressure. So we'll see all of this with various activities. So I'll quickly flip my camera. Okay. Okay, so all of you can see me, right? So I have this. Can I get a confirmation? Am I visible? Okay. Oh, okay. Thank you so much. So, what I have is, I'll show the first. I'll show some activities which is related to the atmospheric pressure. Okay. Now, with the help of, I've taken a small bucket so that I do not spill water on my table. So you see, this is a small bottle, plastic bottle. Okay. Here, the area which is marked red. So this part, I have made a small hole with a pin. Okay. There's a small hole with a pin. Now what I'll do is, I'll fill water inside this bottle. Okay. I'll fill water inside this bottle. Let me color this bottle, color this water so that it is much more visible. Okay. Okay. So I'll just fill this bottle, color this water. Right. So I have made blue water. All right. So I'll now pour water inside this bottle. Okay. So I have filled this. Let me come closer to the camera. So I have filled water inside this bottle. This blue water I have filled inside this bottle, and I have already said that here there is a small hole that I have made with a pin, right? Now what do you observe? I have closed the bottle, but the water is not coming out. Let me slightly press the bottle, okay? I'll keep it in my bag. I'll press the bottle. So when I'm pressing the bottle, can you see the water jet coming out? Is it visible? I'll just bring it closer. So, see? When I'm pressing it, yes. When I'm pressing it, it is coming, right? But if I'm not pressing it, this water is not flowing out of the bottle. There is no water jet, isn't it? There is no water jet, but if I press it, water is coming out of it, isn't it? Now, let me open this. Slowly I'll open this. So when I'm opening this, just 1 second, I'll put some more water because I have already. See what is happening? I'm not pressing this bottle, but the water is flowing out, isn't it? Right, the water is flowing out. I'm not pressing this bottle, but the water is flowing out. Now what I'll do is, I'll simply close this bottle. What happens? I've closed this bottle now. What happens? The water jet stops, isn't it? Now why this is happening is, this is like magic, isn't it? Water is flowing out when I'm opening the bottle. Okay, again I'll open the bottle. See, water is flowing out. You can see this, the water is flowing out. I'm not pressing it. This is simply flowing out. Again, I'll close it. The water jet also stops flowing. Now what happens is that we have air around us, isn't it? We have air. So from all sides, this bottle is also surrounded by air, isn't it? This air will also be exerting some amount of pressure, okay, on this particular bottle from all sides, isn't it? So whenever I'm closing this bottle, okay, whenever I'm closing this bottle, the air pressure is acting on this lid. Now when I'm opening this bottle, now the air pressure will directly act on the liquid which is inside. Okay, so when the air pressure is pressing it downwards, the water is simply flowing out. Okay, so again I'll show you this. So the water simply flows out of the hole. Okay, so this is what is the science behind it. Okay, the atmospheric pressure is primarily responsible for flowing and non-flowing of the water from this bottle. Okay, one more interesting example I can show you for your atmospheric pressure. I'll have to check. I'll put this down. So this is another glass which I have taken, and I'll pour some water inside this glass. Okay, I've poured some water inside this glass. This is a small cardboard, not cardboard exactly. This is just a packing box paper. Okay, cardboard paper which I have with me. Now what I'll do is I will simply place it on top of the glass. Okay, this has nothing but this just water, some drops of water fell on this particular cardboard. Otherwise, this is just a normal cardboard paper. Okay, so I'll just take this. Okay, for this I need to stand up a bit. I'll just take this, place it on top of this particular glass and flip it. Okay, I don't know whether it will get stuck in the first experiment, but I'll try. So slowly, I will try to remove my hand. So what do you see? The water is intact inside this glass and the cardboard doesn't fall off. Though I have inverted the glass of water, right? I have simply inverted the glass of water. Slowly I will remove this, the water flows down. Okay, the water flows down. So here what happens is, now see, the cardboard doesn't stick. Okay, the cardboard doesn't stick. But when I'm doing this, what happens is, the air, atmospheric air, as I have already said, the air, it exerts some sort of pressure on this particular cardboard from the downward direction as well, and it will not allow the glass of water to flow down. Okay, see, it does not fall down, right? So this is also a typical example of your atmospheric pressure. Okay, now for the next activity that we will be doing today is, we will see how liquids exert pressure. As we have already mentioned in our slide, if you go back to the slides which I showed you, okay, the last slide, that is, the liquids, they exert pressure but in different levels. Okay, that means the more deeper you go, the more will be the pressure that it is exerting. Okay, for this I'll just pour the remaining water back to the jar so that I can make use of this water as well. Okay, so now I have this bottle and I have made holes here. Okay, 2 holes here. And when you will pour water inside this, you will see that through the 2 holes, the water comes out, but the distance in which the water jet flows is different. That means from the bottom hole, the water flows to a far off distance because the pressure is higher in the bottom level than the water which is on the top, which flows out from the top hole. Okay, so I'll just pour water on this in this bottle. I need some water. So can you see the lower hole is throwing water to a farther distance than the upper hole. Okay, the lower hole, the water is flowing to this point, but from the upper hole, it is flowing to this point. That means the pressure which is there in the lower hole, okay, the pressure which is there in the lower hole is more than, because the water is less, so the water flow is becoming slightly. See, so because the pressure is more, the water is flowing to a farther distance, okay, farther distance than the top hole, okay. So this is a very, very classical example of how your water or how liquids exert pressure, okay. So from the lowermost hole, it will flow to a far off distance. Again, I'll put some water so that it becomes clear to you all. See. So this is what is happening. Okay. Is it visible? I don't know how visible it is. All right. Okay. Okay. So this is the explanation for how liquids exert pressure. Okay. Liquids will be exerting pressure based on the levels, different levels that it takes. Okay. So I'll just go back to my. So this is what we just saw. The more the depth, the more is the pressure. Okay, so whatever depth, the more deeper we went inside the bottle, the more pressure it exerted and the water jet flew to a farther position than the top hole that was there. Okay, because the depth was less. And the second point also we saw that air around us exerts pressure, which is atmospheric pressure. We saw it with the inverted glass example, and we also saw it with the bottle with the hole. Okay, the moment we closed the bottle, it stopped. The moment we opened the bottle, the water jet started flowing. So this is all because we have atmospheric pressure around us, right? So all of these examples you will be getting in your NCERT books. Okay, all these interesting activities you will be able to do at home. These things are very much commonly used in our houses, and we can prove each and everything that we learn in our textbooks with the activities which are there in those textbooks. So it is highly recommended that you go back to your books, read the activities, do it on your own so that you understand the concepts better. Meanwhile, we will be meeting in the next session. This is all from force and pressure. Okay, thank you so much.
Thank you.
Can I stop sharing the screen?
Yeah, sure. Thank you, Ms. Nupur, for this wonderful session. We all had a great time. Hopefully the students watching mostly on video, we'll also do. And for the closure, like Mr. Benjo, would you like to say anything?
Yeah.
Sure.
So thank you
Please go
all for
ahead.
joining, and special thanks to Ms. Nupu for that wonderful presentation. Today's class was really a fun session, and I know everybody watching will benefit a lot because it's more hands-on, and I think most of the students, I think they have read about this in books but have not seen the activities as you have shown. So again, thank you so much, and to anybody watching us online right now, we do hope and wish that you'll join us for the next one. Again, thank you so much, Miss, for the wonderful session.
Thank you, Benjo, and thanks, Freebirds. It was a great time with you all. Okay. Thank you so much.